Our today's topic is found to be very much important because in our today's lecture, I am going to highlight about the development and the origin of the tornado. Tornado, it's a very important feature, most particularly in the case of the United States of America. Though the tornado is not a regular phenomena in the case of the tropical areas, but the tornado is a very important phenomena in the case of the temperate, and if you march towards the polar region, tornado is found to be a very important and a crucial phenomenon. So, from that point of view, our today's topic is going to be very important because in our today's topic, we are going to highlight what are the different parameters and what are the different factors those are involved in the formation of tornadoes in the different parts of the world. Okay, the formation of the tornado depends on two very important factors. One is the normal lapse rate. I have already prepared one video on the normal lapse rate, and the second one is the dry adiabatic lapse rate. So these are the two very important parameters whenever I will be discussing about the concept tornado. Now, what is the meaning of normal lapse rate and what is meant by the dry adiabatic lapse rate? Normal lapse rate, the term normal lapse rate is very much important in the case of the larger atmosphere. It means if you move upward, the temperature of the atmosphere declines at different rates at the different places of the earth. If you move towards the desert areas, the temperature of the air from the ground surface, it declines at the rate of 25 degrees C per kilometer if you move 1 kilometer in the upward direction, and the temperature will be declining at the rate of 25 degrees C. Now, if you come to a glacial area, it means if you come to one glacial or periglacial areas, the temperature decline rate is found to be very small and minimum. The rate becomes 3 to 5 degrees C per kilometer. So, in the case of the glacial and periglacial areas, if you move upward of up to the depth of 1 kilometer, the temperature declines at the rate of 3 to 5 degrees C. Suppose in the case of the desert areas at the ground surface, if the temperature is 40 degrees C, because at the desert areas the 40 degrees C is of course attained because of the higher amount of the temperature. So in the desert areas, if you move from the ground surface to the upward direction at an altitude of 1 kilometer, the temperature will become 15 degrees C after 1 kilometer of ascent. Why? Because here the normal lapse rate value is 25 degrees C. So from 40 degrees C, the temperature has become 15 degrees C. Why? Because 40 minus 25, so I am getting the temperature value of 15 degrees C. So that is the rate of temperature change in the case of the desert areas. Now, if you go to one glacial dominated areas, in the glacial dominated areas, what happens if the ground surface is having the value of 10 degrees C, maybe the 10 degrees C. If you move up to the elevation of 1 kilometer, the temperature may become 7 degrees C or it may become 5 degrees C. So the rate of decline of temperature with 1 kilometer of ascent is found to be very much higher in the case of the desert areas, while this rate is found to be very minimum in the case of the glacial areas. So these are the very two important differences between the desert and the glacial areas if I talk about the normal lapse rate. So one thing is getting very, very clear that the normal lapse rate value is not fixed. It is changing from one place to another place. All this I have mentioned in the video in my part 1 lecture, which I have covered normal lapse rate and the dry adiabatic lapse rate. But one very important thing is that dry adiabatic lapse rate is found to be fixed. Here the value is 10 degrees C per 1 kilometer of ascent. If you move up to 1 kilometer from the ground surface, the temperature of the air will be declining, a parcel of air, better say, will be declining at the rate of 10 degrees C per kilometer. So, at the ground surface, if the parcel of the air is having the value of 30 degrees C, so if you move up to 1 kilometer of ascent, the temperature value of that parcel of that air will become 20 degrees C of that parcel. So that rate of that parcel of the air is declining following that value 10 degrees C per kilometer, which is known as dry adiabatic lapse rate. Okay. Now the relation between the normal lapse rate and the dry adiabatic lapse rate is very important whenever I will be talking about the origin of the tornado. Okay, say for example, if I talk about one area where the dry adiabatic lapse rate is 10 degrees C because it is fixed, but the normal lapse rate, which is not fixed, here the value may be found to be, though that is an assumed value or fictitious value. Say for example, the value is 15 degrees C, 10 degrees C per kilometer and 15 degrees C per kilometer of ascent. Say for example, these are the values. Okay. Now, if I talk about that, if my y-axis is indicating that this is the elevation, so from the ground surface the elevation is 0. This is 1 kilometer, 2 kilometer, 3 kilometer, 4, 5. So here the y-axis is indicating the elevation in kilometer, the elevation in kilometer. So y-axis is indicating that thing. Now, near the ground surface, say for example, if I draw one parcel, so say for example, this is the parcel, the temperature of the parcel is, suppose it is 40 degrees C. Suppose it is 40 degrees C. Now, the temperature of the surrounding air, it means the air which is surrounding the parcel of the air. It means the temperature of the outer atmosphere. Say, for example, this temperature I am considering 40 degrees C. So the temperature of the parcel of the air is found to be 40 degrees C, and the temperature of the surrounding air at the ground surface is also found to be 40 degrees C. Now, if I move 1 kilometer in the upward direction, the parcel of the air, the temperature will become 30 degrees C. Why? Because in that case, the temperature value is declining at the rate of 10 degrees C per kilometer, following the principle of dry adiabatic lapse rate. Now, if I go to the temperature of the surrounding air, if I move in the upward direction 1 kilometer above, the temperature value will fall at the rate of 15 degrees C per kilometer. So 40 minus 15, the temperature has become 25 degrees C. If I move to another kilometer, so from the ground surface I have reached to the elevation of 2 kilometer from the ground surface, here the 30 degrees C will be converted to 20 degrees C, because 30 minus 10, so what is the value of the 10? 10 is the value of the dry adiabatic lapse rate. So here the temperature of the parcel of the air becomes 20 degrees C. Now the temperature of the surrounding air at the elevation of 2 kilometer from the ground surface will become 10 degrees C. Why? Because 25 degrees C minus 15 degrees C, because the 15 degrees C is the value of the normal lapse rate. So the temperature of the surrounding air is declining following the rate of the normal lapse rate. So the value was 25 degrees C at 1 kilometer. Now after another kilometer, the value has become 10 degrees C. So 25 minus 15, the value has become 10 degrees C. Again, after 1 kilometer, here the value will become 10 degrees C, because 20 minus 10, the value has become 10 degrees C. And now here the value will become minus 5 degrees C. Why? Because 10 minus 15, it is the value of the normal lapse rate. Here I am getting the value of minus 5 degrees C. So just assume the situation. The temperature of the parcel of the air is plus 10 degrees C, and here the temperature of the surrounding air, it means the air which is surrounding the parcel, here the temperature has become minus 5 degrees C. It is not a matter of joke, because the sky which is visible, the temperature of the sky has become minus 5 degrees C. So can you imagine that whatever the sky which we are observing, the temperature of that entire sky has become minus 5 degrees C. It means that will become totally condensed. Why? Because the temperature now is running less than 10 degrees C. So the entire sky will become condensed. So if my entire sky become condensed, so the situation will be like this. This entire sky will automatically descend. This sky will automatically descend to the ground surface. And whenever this sky is moving towards the ground, That type of instability is known as mechanical instability. That is one type of the stability or instability of the atmosphere. So that kind of the instability is known as mechanical instability, where the situation is that the normal lapse rate value is found to be higher than the dry adiabatic lapse rate value. In that case, the entire sky has collapsed, and that sky just making a wheel or just making a spiral, it is touching the ground surface. Now just assume the situation. What will be the situation? Here there is a formation of the low pressure, and once the low pressure is forming over there, it will be dragging the air from the different parts of the atmosphere. So now the air is rushing towards the spiraling of the air, and once the air will be moving towards the spiral air, after reaching to that spiraling, what will happen? If the air of the surrounding places are actually moving towards the spiral, so after moving to the center, it will again move to the upward direction. So what was the previous situation? In the previous situation, there was nothing. The atmosphere was totally calm and cool. Now what happened? That the sky has collapsed, and just making a spiral, the sky has touched the ground surface. Once the sky has touched the ground surface, a low pressure cell has developed at the center of the spiraling. So once the low pressure has been developed, now the low pressure is dragging the air from the different parts of the atmosphere. Now the direction of the air movement has become totally reverse. Now the air is moving in the upward direction. So the phenomena is almost similar to the phenomena of cyclone. But one difference is that cyclone is a wider phenomena covering a place of 200 to 300 kilometer square, but the tornado may be covering the area of 5 to 10 kilometer. Even some of the cases, the tornado covered area may be less than 2 kilometers square. So that is the basic difference of the tornado and the cyclone. And the other difference is that tropical cyclone originates over the seas and the oceans, but the tornado originates over the land surface. So the fundamental thing is that the low pressure is being developing at the center, and it is dragging the air towards its center. Now the picture ski situation is like this. So once the cloud is touching the ground, the air will be moving towards the center. Air will be moving towards the center, and now the air just making a wheel, it is moving to the upward direction. And just look at the diameter, or whatever the perimeter you can say, just look at the diameter or perimeter of the tornado. It is very smaller. Now once a tornado is moving through one place, it is dragging the air. So it is advisable, or it will be advisable, to open the doors and the windows of the buildings, so that the air from the houses or your homes may rush towards the tornado. If you close all the doors and the windows of the building, so what will happen? The air will ultimately collapse your wall, or it may collapse your gate, it may collapse your doors to move towards the center of the tornado. It may move by collapsing your walls, by collapsing your doors, and the perfect intention of the air is to move towards the center of the tornado. Tornado is a regular phenomena in the case of the temperate areas. That is a regular phenomena in the case of the temperate areas. It is not a very regular and a prominent phenomena in the case of the tropical belt. Now, why? In the case of the tornado, what happens? The cloud is touching the ground. Say, for example, this is the cloud. So the cloud is touching the ground by making a spiral. Now, for the formation of the tornado, the height of the tropopause should be 12 to 10 kilometer from the ground surface. So the height of the tropopause should be lesser. And that height of the tropopause is visible near the temperate areas during the time of the winter. During the time of the winter in the temperate belt, the height of the tropopause become 12 to 10 kilometer or 10 to 12 kilometer from the ground surface. So the cloud may automatically touch the ground surface because of the smaller distance of the tropopause from the ground surface. In the case of the tropical belt, what happens? The height of the tropopause remains 70 to 20 kilometers from the ground surface. So it becomes very difficult for the cloud to touch the ground surface by making a spiral because of this greater elevation difference between the ground and the tropopause. But here the difference is less, the heightal difference is less. So the cloud, by making a spiral, by making a hook means the situation is like this. By making a hook, the cloud may automatically touch the ground surface and it can ultimately be culminated into the tornado. So the tornado is a regular phenomena in the case of the temperate belt. In the America, tornado has become a very regular phenomenon. California has become the tornado alley because of, on an average, 30 to 35 tornadoes generate in that particular place. But if you come to the tropical belt like India, Bangladesh, Myanmar, in that place, tropical belts, the tornado is not a very regular phenomenon. So this was the explanation of the tornado. So just the essence, the tornado is forming because of the mechanical weathering, mechanical, not weathering, mechanical weather stability phenomena, stability, and better say mechanical weather instability phenomena. And when the normal lapse rate, the value of the normal lapse rate is found to be higher than the value of dry adiabatic lapse rate. So thank you. It was the discussion about the formation of the tornado. Now the discussion about the normal lapse rate and the dry adiabatic lapse rate has been there in my part 1 lecture, which is available in the description section. Thank you.